Hey there, today we're diving into VLANs, that's Virtual Local Area Networks. So let's jump right in and start. A LAN is a collection of devices connected together in a physical location, for example, your office, or even more relatable, your home. Devices in the same LAN are typically also in the same broadcast domain, and this means that broadcast messages are received by all the devices in the network. This can get out of hand very quickly, especially if there are lots of devices in the network. And also, everyone can access resources shared in the LAN unless other security measures are implemented. To solve this problem, you could get more equipment to physically segment the network, or you could also introduce a router inside the network to break up the single broadcast domain into multiple broadcast domains. Obviously, this introduces more overhead and cost requirements. VLANs let you segment your network into separate virtual networks within the same switch. Basically, each VLAN is its own broadcast domain, keeping traffic isolated. So before you configure VLANs, all the ports are usually in VLAN 1, and we call this the native VLAN. Let's go ahead and look at a quick example. Picture a network with 3 departments, right? That's HR, Finance, and IT. Using VLANs, we can segment these departments. All we need to do is create the relevant VLANs and assign ports that connect devices in each department to the same VLAN. For instance, you could configure VLAN 10 for HR, VLAN 20 for Finance, and VLAN 30 for IT. Then once you do that, you assign the relevant ports to the appropriate VLANs. So what if these VLANs span across multiple switches? How are frames sent to the right VLAN on a device in a different switch? That's where trunking comes in. Basically, trunking allows frames from multiple VLANs to be transmitted over a single physical link between switches, and both switches are connected via trunk ports. A trunk port basically allows traffic from multiple VLANs to be carried through between different switches. The opposite to trunk ports is what we call access ports, which are used to connect end devices to the network. Using 802.1q tagging, the switch adds a VLAN ID to each frame before it crosses the trunk. The receiving switch then uses this ID to forward the frame to the correct VLAN. Finally, here is the Ethernet header format, and of importance here is the tag field. When we zoom into this field, we can see that the tag/protocol ID field identifies the protocol in use. In our case, this is just 802.1q since we're talking about VLANs. And the VLAN ID identifies the VLAN number. Since the VLAN ID is 12 bits, we can have up to 4096 VLANs. That's from 0 up to 4095. So I know the maximum is 4095, but we talked about 4096 VLANs, right? Remember, 0 is also counted. Talking about 0 and 4095, these two are reserved, right? You can't configure VLAN 0 or VLAN 4095. That's it. I hope you found this video informative and learned something new. See you in the next one.